Okay, so in this video I'm going to have a look at deriving the sine rule, or the sine formula, which is a over sine A is equal to b over sine b, which is equal to c over sine c. So the small a, b and c on top here, they're the three sides of the triangle, and the large a, b and c here, the three angles in the triangle. So we go down through the usual process: given to prove, construction and proof. So I'm going to start with what we're given. We're given a triangle ABC, and I've drawn the triangle in two different ways. We're going to do two cases here. So the first case is where A, B and C is like this here, where the angle C here is an acute angle. And here we have the triangle ABC, where the angle C is an obtuse angle, or greater than 90 degrees. Now I've identified the sides and the angles here. So you've got this vertex here is A, so its opposite side is small a. This is a vertex B, or angle here at B, and its opposite side here is small b, and so on. Same on this side here. So that's what we're given. What we want to prove is this here. I've done that already. The construction then: in each triangle, draw BD perpendicular to AC. So what you're going to do is drop a line from B down here to D, where this angle here at D is a right angle. You do the same here, but in this case, to draw a line down, you've got to extend AC out along here, outside the triangle, and then drop your line down here to D, and this is a right angle here. Okay, so that's our construction, and now we've got to go through the proof. Now I'm going to do the proof in two cases here, in both cases, the acute and the obtuse case. So let's start. Now the first thing I'm going to do is find the sine of A. So I'm going to find the sine of our angle at A. So in both cases, so sine A is equal to, let's see what it is in both cases. So in our first case here, this is our angle at A, and if you look at this triangle here, this is a right angle triangle. The sine of that triangle, of this angle here at A, is the opposite over hypotenuse. The opposite is BD, and the hypotenuse is the length C. So it's BD over C. In this case here, we have our angle at A, and in this case here, we have a right angle triangle which is extended out to here. So this is our triangle that we're looking at, and the opposite side for angle at A is also BD, so it's going to be BD over the side C. So in both cases, it's BD over C, BD over C. So we'll just write that out here. So it's going to be the length BD over the side C. It's going to be the length BD over the length C. Okay, so that's the first part. Second thing we're going to do then is find the sine of C in both cases. So we're going to find the sine of C and the sine of C. So let's have a look at that. Now this is our angle here at C, so we can see that that's going to be BD over A. BD over A, opposite over hypotenuse, is going to be the sine of C. Now in this case here, our C is here, but we're going to look at this triangle here, this little triangle out here. So we're going to look at this angle here first of all, and that's going to be 180 degrees minus our angle at C. Remember, this is our angle here at C. So if we want to find the sine of this angle here, so the sine of this angle here is going to be, that's going to be 180 degrees minus C. That's this angle here. That's going to be opposite again, so it's going to be BD over A as well. That's also going to be BD over A, small a. Now remember, if you go back to our sine, cos and tan in each of the quadrants, sine, cos and tan is positive here in the first quadrant, and sine is positive here in the second quadrant. So if we find the sine, say for example we have this angle here, the sine of this angle here is going to be the same as the sine of the reference angle, because sine of sine of this angle here is going to be positive because it's in the first quadrant. And really this is the same thing in reverse. If you switch this around the other way, you see this is our obtuse angle, this is our acute angle here. So it's the same kind of thing. So we end up anyway, this sine 180 degrees minus C is going to be exactly the same as the sine of C. So in both cases we've got the sine of C. The sine of C is BD over A. So let's just write that out. The sine of C is going to be BD over small a. It's going to be BD over small a as well. Okay, so what I'm going to do now is just divide both of these equations. So what you're going to do is divide this equation here by this equation here. So what you end up with is sine A over sine C. So I'm going to take sine A over sine C. This equation divided by this equation. That's going to be BD over C divided by BD over A. And if you look at that, it's going to be the same in both cases, both obtuse and acute cases. So if you look at that, again, you've got sine A over sine C. Now here we've got a fraction divided by a fraction, so I'm going to flip this one upside down and multiply. So you end up with BD over C multiplied by, we have to flip this one upside down, remember? So that's A over BD. A over BD. So if you look at the right hand side, well, we'll just write this out again. Sine A over sine C is going to be equal to, remember this, this will just cancel with this or divide into it, and you end up with just A over C. So sine A over sine C equals A over C. Now, this is the bit you've got to remember then. If you multiply the left hand side and the right hand side here by C over sine A, so what we're going to do is multiply both sides by C over sine A. So this is what we're going to multiply both sides by. So let's do that. So sine A over sine C, that's on the left hand side, and on the right hand side we've got A over C. I'm going to multiply both sides by C over sine A, C over sine A. What happens here now is you end up with this will divide into this, and you end up with C over sine C equals, and remember this will divide into this here, so you end up with A over sine A. This is part of our sine rule. It's C over sine C is equal to A over sine A. So this is one part of our sine rule. So we've proven, we've derived one part of our formula anyway. Now, in a similar manner then, what we could do is draw a perpendicular. If I go back up here again to our two triangles, we could draw a perpendicular from C to AB. So I could draw a perpendicular up along here, and I could draw a perpendicular from here up to here. Repeat the whole process again, and what you would end up with if you were to do that, I won't go through the process, maybe you could try that yourselves, but you will end up with A over B is equal to sine A over sine B. or then if you multiply out as we've done up here, you would end up with a over sine A equals b over sine b. Now I won't go through this in detail, you can try that out yourselves, but this is the general procedure on how you would do it anyway. Okay, and that's it.